Simplifying radicals. When simplifying radicals, start with the prime factorization. And so you've done prime factorization since 4th and 5th grade. You end up with a number 10, and you are asked to find the prime factorization. So you're going to start with your lowest prime number, which is 2. 2 times 5. Both of those are now prime numbers. You've factored out the terms that are prime. Then you're going to remove pairs. So if our prime number, or if our number was 25, our prime factorization would give us 5 and 5. Our pairs would be 5. We're going to multiply the remaining singles, both sides inside and outside the radical symbol. So now we're taking our concept of prime factors. We are assuming that we had a value inside a radican, so like the square root of 25, and something outside, say 3. So we're saying 3 times root 25. Our prime factors of 25 are 5 and 5. So we're still looking at the root of 5 times 5. I pull out a pair. So I end up with 3 times 5 remaining. We're going to look at lots of examples of these with some I try, you tries. The first I try, root 84. Now root 84, we're going to start with our 84 and take out our factors. So our first set of factor is 2, gives me 42. Divided by 2 again, because it's an even number, gives me 21. 21 can be divisible by 3, which gives me 7. Well, the other thing I can factor down is the m, because m is actually a m squared times m squared, which is a m times m times m times m. Now, we're looking to remove our pairs, so let me write this all out in expanded form so it makes a little bit more sense what we mean by pairs. We have, in this radican, square root of 2 times 2 times 3 times 7 times m times m times m times m. That is our expanded form within the radican. And so we're looking for pairs. I see I have a pair of 2's there, I have a pair of m's there, and I have a pair of m's there. For every pair, we're going to eliminate the pair and bring one of that item outside of the radican. If it doesn't have a pair, it remains inside the radican. And then when we're all done, we combine things back together. So 2 times m is going to be 2m squared. 3 times 7, 21. And so our final solution is going to be 2m squared root 21. I want you to pause the video, take a moment to try the you try. Welcome back. Root 25 x cubed. You should have ended up with a final solution of 5x root x. Let's try another one. Negative 2r squared root 28 r to the 6th power. And so we're looking for our factors of 28. And I'm going to do this a little bit differently. I'm going to go ahead and take my 28 up here so that I can factor it down. So our factors, since it's an even number, 2 and 14, and then 14 is an even number, so that gives me 2 and 7. And I can see that I have a pair of 2's, and the 7 is going to remain in. Now, the other shortcut I want to go ahead and tell you is anytime we're taking the square root of an r to the 6th power. One of the things we talked about last year was that the square root of 4 is the same thing as saying 4 to the 1/2 power. Knowing that we can write the problem that way for both of those helps make it far easier for us to simplify our variables to a power. Because I can simply say r to the 6th power raised to the 1/2 power. That's the same thing as saying the square root of r to the 6th power. And when we see it in this form, we realize, hey, I have a power raised to a power, so I multiply those together. 6 times 1/2 is 3. That simply equals r to the 3rd power. And so that's how that will simplify. That will expedite our work a good bit here. So r to the 3rd power is going to come out. One pair of 2's is going to come out. And the root 7 will remain in the radicand. Now we simply take our pieces and add them, or multiply them together. Negative 2 times 2, well, that's negative 4. R squared times r cubed. We have like bases, so we add the powers. That would be r to the 5th power. Can't do anything with the root 7, so it remains. Again, go ahead and pause the video. All right, you should have gotten 18w to the 5th 2w. Next, we have 4 times root 25 x to the 16th power over 49. Now, these can be very tricky. We need to look very carefully to where the 4 is. If the 4 is in front of the radicand, then we're saying 4 times. If the 4 is sitting up here, then we're saying the 4th root. So that 4 has got to be physically in this space. We're not saying 4th root. We're saying 4 times. So I'm going to erase that there by drawing through it. So we have 4 times. And anytime you have a radical with a fraction, a lot of times it is easier to split the fraction. So I'm going to do that. Square root of 25 x to the 16th power over the square root of 49. It's an equivalent. All I did was split the fraction. So now we can start to clean this up. We have 4 times root 25. Well, that's 5. X to the 16th to the 1/2 power. Well, half of 16 is 8, so that's x to the 8th power. Both of those have come out of the radical. Over top of root 49, that's 7. At this point, we simply clean up the problem by multiplying across the top, multiplying across the bottom. 4 times 5 is 20. X to the 8th. 1 times 7 is 7. So our final answer is 20x to the 8th over 7. I will also take 20 over 7 x to the 8th power. Generally, it is probably going to be more common for you to just see it simplified in this fashion. Go ahead and pause the video again, taking note that the next problem is 5 times the root of 90y to the 7th over 625. Welcome back. You should have ended up with a final solution of 3y to the 3rd root 10y over 5, or we could say 3/5 y to the 3rd root 10y. Now these are your examples where you see the 4 is actually over the radicand. It's not sitting right out in front of it. Now the 4 means we're no longer dealing with square roots. We're dealing with 4th roots. So instead of looking for pairs, which is what a square is, something times itself, we're looking for fourths. Something times itself, times itself, times itself again. So we're really going to want to factor down this 162. So 162 gets factored down. Dividing by 2 gives us 81. 81 is divisible by 3. Gives us 27. And by 27, we should realize that's a cubed root. Which is a factor of 3 times 3 times 3. Okay. Well, let's take what we know. We're looking for the 4th root of 2 times 1, 2, 3, 4 threes. Times. Now, one of the things we can do with the r's, remember our rule for multiplying variables. R times r is r to the 1st power times r to the 1st power adds up to r squared. Now, one of the things we did last year was work backwards. I gave you a value like r to the 8th and asked you to represent an expression that simplified to r to the 8th. And so you would represent that by saying something like r squared r to the times r to the 6th. Well, that's what we're going to do down here. We're going to break that r6 up into an expression r to the 4th power times r squared. And so we're looking for our sets of 4. I see a set of 4 here. Our r to the 4th power is itself a set of 4. So let's bring all of that out. We'll bring one of the 3's out. We'll bring the r out because those are our 4th root sets. Everything else will remain in the 4th root radicand. 2 remains in there and r squared remains in there. And that's it. That's our final answer. So doing a 4th root is no different than doing a square root. The only big difference is we're looking for 4 of an item rather than just 2 of an item. Anybody feel like we're playing Yahtzee yet? All right. You pause the video, give the next one a try. Notice that you're looking for the cubed root, so you'll be looking for 3 of an item. Welcome back. You should have gotten 3x root 3 of 2. 3x root 3 of 2. Adding and subtracting radicals. The coefficient is the number in front of the radicand. Like terms with radicals means everything except for the coefficient are the same. Now, last year I related the radicand and we said that it functions like a variable. So if I have 2a, the variable is a, I can only add that to something else that has a as an exact variable. If I have 2a, I cannot add that to 2ab. ab is not an identical variable to a. So we're going to see a little bit of the same as we're working through radicals. When you add or subtract with radicals, combine the coefficients of the radical with like terms. Don't forget to simplify as needed. This may have to come first. So sometimes you'll find that you can combine radicals and then simplify. Other times you will find that you need to simplify the radical to be able to figure out what you can add together. So let's look at our first example. We have root 40 minus 2 root 40. So thinking in terms of variables, that would be kind of like saying a minus 2a. Well, those are like terms, so we can combine them, and we are going to combine them. We have 1 root 40 minus 2 root 40. So 1 minus 2 is negative 1 root 40. Well, now I realize root 40, man, that's a pretty decent sized number. It could probably factor down. So 40, our factors of 40 are 4 and 10. Well, 4 is a perfect square. That definitely has a root. And so the square root of 4 is 2. So I have a negative 1 getting multiplied by 2. And what's left in the radical, I don't need to factor down the 10. You should know that by now because that is a combination of 2 and 5, and both of those are prime numbers. So when I put it in the radical and I multiply back together, we're going to have 10. So we'll leave it as root 10. Root 10 is a fairly common one that you see quite often. And then we multiply together what's on the outside. Negative 1 times 2 is negative 2 root 10. That'll be our solution. All right, go ahead and pause the video and give the next one a try. All right, welcome back. You should have ended up with 26 root 3. 26 root 3. All right, next problem. Root 20 plus 3 root 5. Well, those aren't like terms. That's a 20, that's a 5. That'd be kind of like saying A and B. This is one of those examples where we need to factor down or simplify that radical to see if it will end up having a like term. So 20 is going to factor down to 4 and 5, where 4 is a perfect square. So the square root of 4 gives me 2 times root 5. That's the simplified version of root 20. Well, now we should be thinking to ourselves, 2 root 5. Root 5 and root 5, those are like terms now. Those are the same radical. So we can add them together. Plus 3 root 5. 2 plus 3 gives us 5 root 5. All right, you give the next one a try. Welcome back. You should have ended up with negative 12 root 11 minus 8 root 55. Now this one was a little bit tricky because when you saw that both of these were divisible by 11, you were probably thinking, hey, I'm going to end up with a root 11 and I can simplify both. Nope, can't do that on this one because the root 5 is a prime number, where root 9 is a perfect square. So root 9 is going to simplify out. Root 5 will remain in and will have to get multiplied back together. So negative 12 root 11 minus 8 root 55. All right, last one. 5 root 80 x cubed minus x root 5x. So the first thing we need to do is deal with that 80 x cubed to see if anything is going to simplify. So I'm going to pull that off to the side. 80x cubed. And really, I'm only interested right now in the 80. So 80's got factors of, let's make some big numbers so we can jump down fast. 8 and 10, where that would be a 4 and a 2. And this would be a 2 and a 5. And so now I can see real quick that I have a pair of 2's. 4 times 4 is also a pair of 2's. And we're going to have root 5 left inside. X cubed would be x squared times x. So I will have x squared as my pair coming out. So right now let's figure out just what's coming out. We'll pull out a 2. We'll pull out another 2. We'll pull out an x. And we're leaving in 5x. Ooh, wow. That's nice to know. If we're leaving in 5x, that means we're going to have a like radical. So let's simplify this. 2 times 2 is 4x root 5x. But remember, all of this represented just the value of root 80x cubed. So we still have to take our 5 times the value of root 80x cubed. And we have to multiply on the outside. 5 times 4 is 20. X root 5x. We're subtracting x root 5x. And those are like terms now, because the root 5x is the same on both terms. 20x minus x, well, that will end up being 19x minus root 5, not minus. That'll be 19x root 5x. All right. Pause one more time and you try. Now this one ended up a little bit messier. Notice that our factors were 9, 5, and 4, where the 9 pulled out a 3, the 4 pulled out a 2, the x to the 12th pulled out an x to the 6th, and that left the root 5 all by itself inside. On my right expression, the 20x to 11th, which should have been a big indicator that we were not going to have like terms, because if I took the square root of x to the 11th, we know we're going to end up with an x still in the radicand, which would make it different from not having an x in the radicand. But let's go through this. Root 20 is going to be root 5 times 4 times root 10 times root 1. All right. Root 4 is 2, so that's going to come out in front. X to the 10th is going to x to the 5. So we can multiply those together. 3 times 2 is 6. X to the 5th, root 5x. And that will be our final answer.